This is Doug at CDF Training. I'm going to teach you how to do Boyles Law, one of the most easiest, most memorable ways that I love teaching it this certain way. Not hard to do. What happens is a lot of time guys in the industry say, I'll never use Boyles Law, just give me a quotation or give me the answer for these. No, you didn't learn. I'm going to teach you how to actually use it in a practical world. Now, if you use it, that's totally up to you, but I'm going to show you how to do it. All right. Mother Nature. P1 and V1, I like to tell everybody that P1 and V1 is Mother Nature's pressures and volumes. And we usually know Mother Nature's pressure as formation pressure. And we know the volumes as pit gains on the surface, right? So that's what happens. Gas comes in, expands, and pushes out the equivalents, right? Now, on the right side, you got P2 and V2, right? This is hydrostatic pressure. That is the pressure that you push against Mother Nature with. That's my side. That's what I use to keep Mother Nature off of me. So my side is going to be P2. Now there's a couple different things you can use for P2. P2 can be hydrostatic pressure, column and non-moving fluid. You can also use P2 as a maximum, meaning anywhere in that wellbore, let's just say your shoe pressure, you can't exceed that pressure. You can actually say, all right, this is the maximum, and that will be gas bubble size at that maximum pressure. Or you could say, when it gets to surface and I have 200 psi on my choke, how big is the gas bubble? That's how it works, okay? And the V2 is usually volume. What is the volume of gas at depth, okay? And then gas up near the surface. So P2 can be hydrostatic, can be maximum, and the last one is what we call atmospheric. It's 33 feet down from the surface. So we want to know when gas comes out on surface, how big is it going to be? We use atmospherics, 14.7 psi. Okay? So let's go ahead and start working this. You shut in your wellbore. I walk up to your rig floor and I see all this data recorded, just like it's supposed to. You got shut-in drill pipe pressure showing you 200, shut-in casing pressure showing you 500. You got a mud weight of 12 pounds. You got a TVD of 8,500 feet, and you got a pit gain of 8 barrels. So how does this work with this Boyles Law I'm teaching you? First things first, start over here on the left-hand side. What's Mother Nature's formation pressure? We don't know it. We don't know it, but we can figure it out through formulas. And the formula for that is going to be hydrostatic pressure plus shut-in drill pipe pressure. Remember, shut-in drill pipe pressure represents how much under balance you are in your wellbore. Now volume. How much volume from the pressure does she give you? Well, Mother Nature gives you 8 barrels. So that means your volume is 8. We know it because we have a pit gain of 8 barrels. Now we go to P2. Well, in this case, what is pushing against Mother Nature? I don't have no maximums that I'm worried about. It's just simply hydrostatic. So in this case, you just do hydrostatic math. So you got to take your mud weight times 0.052 times your TVD. So you go 12 times 0.052 times 8,500 feet. And that gives you the grand total of 5,304. So 5,304 psi. And the V2, I want to know what the true size of the gas bubble is. So if I know hydrostatic pressure is 5,302, and I want to know what formation pressure is now, I take shut-in drill pipe pressure and add it. So 5,304 with 200 psi shut-in drill pipe pressure gives me 5,504. You just solved Boyles Law, guys. It's not that hard. Now, Boyles Law is broken to 2 different formulas. You will have to solve for P2 or you will have to solve for V2. No ifs, ands, or buts. So you have to solve for pressures and then volumes. In this case, I want to know what true bubble size is at depth. Remember, this takes in case in point solution gas. Okay. So what we got to do if we're going to solve for V2, there's a whole other formula. It says if we're going to solve for V2, I take P1 times V1 and I divide that by P2. We know in math, when we come across an equal sign, we're going to go ahead and divide. So let's go ahead and do what we're supposed to do now. So 5,504 times 8 equals divided by your hydrostatic pressure, 5,304, gives you the grand total of 8.3. So what that means is your V2 is 8.3. And why is this important? Well, what happens in our industry, we just say, hey, 8 barrels. We start making room for our tanks to have X amount of returns as that gas bubble is coming up the wellbore. But when you get into volumetrics and the lube and bleed, that right there is something that has to be accounted for. Now, generally, most people would just forget it. But this is why Boyles Law is so important. That 0.3 right there turns into massive size on the surface. That 8.3 barrel in the ground is going to be closer to 30 barrels, 20 to 30 barrels when it gets to surface. So you have to account for it, and Boyles Law is the only formula that tells you that. So the key is, you did have an initial kick of 8 barrels, but what you didn't see was this 0.3 that was in solution. So be very careful. That's how you do it, Boyles Law. Simplistic formula if you understand. Left side's Mother Nature, right side's me. P2 is going to be, a couple little things again. P2 is going to be atmosphere, or what we call atmospheric. It's going to be hydrostatic. Or the last one is max. Boom. Boyles Law. Like, follow, share CDF training.